Hello everyone, welcome back to my channel. Have you ever wondered how mathematicians can find HCF, LCM, and even the number of zeros at the end of a number without actually calculating everything? What if I told you that every number in the world has a secret fingerprint? Yes, every number has its own unique identity. Today we are going to uncover one of the most powerful concepts in mathematics, that is fundamental theorem of arithmetic. And trust me, by the end of this video you will be able to solve board questions easily and understand why this theorem is called DNA of numbers. Let's begin. Imagine you bought a Lego castle. No matter how big the castle is, it is made from smaller blocks. Similarly, every composite number can be broken down into smaller building blocks called prime numbers. Can every number be broken into a smaller numbers? What about 24? 24 can be written as 2 into 12. Again, this 12 can be written as, that is 24 is equal to 2 into this 12 can be written as 2 into 6. 2 6 are 12. Now again the 6 can be written as 24 is equal to 2 into 2. Already it is there. And 6 can be written as 2 3 times. Further we cannot divide 3. So completely 24 can be divided into 2 into 2 into 2 into 3. Interesting, right? But here is the shocking question. Can 24 be broken into prime numbers in some completely different way? Or is only one unique prime factorization? Today we are going to discover one of the most powerful ideas in mathematics, that is the fundamental theorem of arithmetic. The theorem that forms the foundation of number theory, cryptography, computer security, HCF, LCM, and many more board exams. Today in this video, we are going to learn about the prime numbers revision, prime factorization, and the big theorem, that is fundamental theorem of arithmetic, then real life applications, board exam questions on HCF, LCM, and other important problems and challenges and activities. By the end of this video, you will understand the theorem perfectly, solve the board exam questions, learn real life application, take part in exciting challenges, avoid common mistakes students make. So grab your notes and let's begin. Before understanding the theorem, let's revise prime numbers. You know that a prime number has exactly two factors, that is 1 and itself. Examples for the prime numbers are 2, 3, 5, 7, 11, 13, etc. because all these numbers are having the factors as 1 and itself. We'll have a quick activity. Each of these are prime: 21, 23, 27, and 29. Comment your answer below. Okay, here 21 is not a prime number because it is having the factors like 1, 3, 7, 21. But 23 is having only 1 and 23. So 23 is a prime number. 27 is again a composite number. It is not a prime number because it is having factors 1, 3, 9, 27. But 29 is a prime number. So here 23 and 29 are prime numbers. Why are prime numbers special? Think of prime numbers as a Lego blocks. Every structure built using Lego pieces. Similarly, every number is built using a prime numbers. See here, 12 is having a factors 2, 2, 3, and 18 is having a factors 2, 3, 3, and 30 is having 2, 3, 5 as a prime factors. Even 2, 3, 2, 3, 2, 3, 5, all these are prime numbers. So prime numbers are the building blocks of mathematics. Every composite number can be written as a building block of prime numbers. Let's factorize some numbers. Let's take an example 36. Let's form a prime factor tree. That is 36 can be written as 2 into 18. Again 18 can be written as 2 into 9. Again 9 can be written as 3 into 3. 3 we cannot again further divide because it comes like 3 one time. So we have the numbers like 2 into 2 into 3 into 3, which is equal to 36. Therefore, 36 is equal to 2 comes how many times? 2 times, that is 2 square, and 3 comes how many times? 2 times, that is 3 square. So 36 is equal to 2 square into 3 square. Let us take one more example, that is 72. How we are dividing 72? So 72 can be written as 2 into 36. Again 36, the same way we can divide as 2 into 18. Again 18 can be written as 2 into 9. 9 can be written as 3 into 3. So the factors are 2 into 2 into 2 into 3 into 3, which is equal to 2 power 3 into 3 power 2. So 72 can be written as 2 cube into 3 square. Now it's your turn. Pause the video and find the prime factorization of 84. Got the answer? We'll cross verify. 84 can be written as 2 into 42, and 42 again we can divide it as 2 into 21, and 21 can be written as 3 into 7. So overall we can write it as 2 square into 3 into 7. So 84 can be written as 2 square into 3 into 7. If you got this answer, you are in the correct path. Now comes the exciting part. Let's factorize 60. 60 can be written as 2 into 30, and 30 can be written as 2 into 2 into 15. And 15 can be written as 3 into 5. This is one method, that is 2 square into 3 into 5. I'll show you another method. This is first method and this is second method. That is 60 can be written as 6 into 10. Again 6 can be written as 2 into 3, and 10 can be written as 2 into 5. Now we can write it as 2 square into 3 into 5. Same answer but different method, right? We'll solve it in another one more method, that is 60 can be written as 12 into 5, and 12 can be written as 2 square into 3 into 5. So the same answer, right? Always you will get the same answer, but we are using a different method. Now let's move on to the main part of this topic, that is what is fundamental theorem. Every composite number can be expressed as a product of prime numbers, and this factorization is unique except for the order of factors. We'll understand the statement of fundamental theorem of arithmetic. Every composite can be expressed as a product of prime numbers, and this factorization is unique except the order of the prime factors. Simple meaning, right? Every number has prime factorization. Only one unique prime factorization. We'll take the previous example. In the first method, we divided 60 as 2 into 30 and we got this answer 2 square into 3 into 5. In the second step, we divided 60 as 6 into 10, and in the same, but the final answer is 2 square into 3 into 5. And in the third step, we divided 60 as 12 into 5, but the final answer is 2 square into 3 into 5. Same factors, only order changed. So this is the fundamental theorem of arithmetic, means every composite number can be expressed as a product of primes, and this factorization is unique. Whatever may be the order of the factors, but the factorization is always unique. Imagine every number has an Aadhaar card. For example, see 20. 20 can be written as 2 square into 5, and 36 can be written as 2 square into 3 square. 72 can be written as 2 cube into 3 square. No two numbers have the same prime factorization. That's why prime factorization acts like a unique identity card. Let's solve few more problems on prime factorization method. The first one is factorize 84. 84 can be written as 2 into 42. Again, 42 can be written as 2 into 21. Again, 21 can be written as 3 into 7. So the factors are 2 into 2 into 3 into 7. So it can be written as 2 square into 3 into 7. This is the prime factorization of 84. Let's take one more example. Factorize 180. So 180 can be written as 2 into 90. Again 90 can be written as 2 into 45. Again 45 can be written as 3 into 15. 15 can be written as 3 into 5. So we can write it as 180 is equal to 2 into 2 into, you can take these numbers, 3 into 3 into 5, that is 2 square, 3 square into 5 is a prime factorization of 180. Now pause the video and find for 126. Got the answer? If you got the answer as 2 into 3 square into 7, then you are correct. Now we'll learn few real life application in internet security. Whenever you use online banking, ATM, UPI, password protection, prime numbers are working behind the scenes. Large prime numbers help create encryption system. Another application is computer science. Data security uses prime factorization. Breaking huge numbers into primes is difficult. That's why hackers struggle. And one more application is finding HCF and LCM. Prime factorization helps calculate HCF LCM quickly. And we use in cryptography, that is RSA encryption used in every HTTPS website is based on multiplying two large numbers that can't be easily reversed. The fun fact is, even supercomputers find it difficult to factorize extremely large numbers. That's why prime numbers are so valuable. Now we will solve some board exam questions. The first one is find the prime factorization of 540. How to find the prime factorization of 540? 540 can be written as 54 into 10. Again, 54 can be written as 2 into 3 into 3 into 3, and 10 can be written as 2 into 5. So overall it can be written as 2 square into 3 cube into 5. So this is the prime factorization of 540. If you are not getting how to write 54 directly like 2 into 3 cube, you can divide it like 54 can be written as 2 into 27. Again 27 can be written as 3 into 9. 9 can be written as 3 into 3. Therefore, 54 we can write it as 2 into 3 into 3 into 3. That is 2 into 3 cube. So easily we can solve it in two steps. Now we'll move on to another question, that is find the HCF of 24 and 36. How to find the HCF of 24 and 36? Using prime factorization method, first find the prime factors of 24. So prime factors of 24 is, we can write it as 2 into 2 into 2 into 3. 24 can be written as 2 into 2 into 2 into 3, that is 2 cube into 3. And 36 can be written as 2 into 2 into 3 into 3. That is 2 square into 3 square. Now the common factors are, here what is the common factors? 2 square, big 2 square, and here what is the common factors? 3. Therefore HCF is equal to 2 square is 4. 4 3 times is 12. So 12 is the HCF. So whichever the number they are giving, first write the prime factors, then find the common factors. The common factors become HCF. So whenever you want to find HCF of any two numbers using prime factorization method, first find the prime factors of two numbers Then find the common factors. The common factors become the HCF of the given numbers. Let's move on to the next question. Find the LCM of 18 and 24 using prime factorization. First, find the prime factors of 18, that is 2 into 3 into 3, that is 2 into 3 square. Then 24 can be written as 2 into 2 into 2 into 3, that is 2 cube into 3. Now you have to find the highest power in this. In 2, which is the highest power? 2 cube. And in 3, which is the highest power? 3 square. Therefore, LCM is equal to 2 cube into 3 square. Always we have to choose the highest power in the given number. That is 8 into 9, that is 72. So LCM of 18 and 24 is 72. Find whether 6 power n can end with the digit 0. Always a number ends with 0 is having the factors as 2 into 5, because 2 5s are 10. It must have 2 and 5 as a factor. Then we'll take 6. 6 factors of 6 are 2 into 3, but it doesn't have a 5. Here 2 is there, but there is no 5 in this. Therefore, 6 power n cannot be end with 0. So, if you want to find a number ends with 0 or not, means it must have the factors 2 and 5. This is the frequently asked question in your board exam. Now it's a challenge time for you. Find the prime factorization of 126. If you got the answer as 2 into 3 square into 7, you are correct. Now pause the video and find the HCF of 72 and 108. In the first step, find the prime factors of 72 and find the prime factors of 108. Then you write the common factors. In these two, the common factors are 2 square and 3 square. So 2 square into 3 square is 36. So 36 is an HCF of 72 and 108. Now pause the video and find the LCM of 15 and 20. First, find the prime factors of 15, then prime factors of 20. Then you write the highest power of each factors. So 2 square is the highest one, then 3, then 5. So 2 square into 3 into 5 is 60. So 60 is the LCM of 15 and 20. Now it's a super challenge for you. Without calculator, find the number of factors of 360. How to find it? Have you got the answer? First, find the prime factorization of 360, that is 2 cube into 3 square into 5 to the power 1. So the number of factors are 3 plus 1, 2 plus 1 and 1 plus 1. You have to consider the powers here. So 3 plus 1, 2 plus 1 and 1 plus 1, that is 4 into 3 into 2, that is 24 factors. So 360 is having 24 factors. So to find the number of factors of a number, first find the prime factorization of the given number, then powers multiply with the next number of each power. Then you will get a number of factors. So today we learned prime numbers, prime factorization, Fundamental Theorem of Arithmetic, Real Life Application, HCF and LCM, and board exam trick, that is 6 power n, factor count, and termination. There is a final mega challenge for you. Comment below what is the prime factorization of 756. Subscribe for more grade 6 to 10 mathematics video. Like if you learned something new. Share with your friends preparing for board exams. Comment your answer to the challenge. Remember, every big number has a secret prime identity waiting to be discovered. Thank you.